In this video, we will use a dictionary to abstract the idea of a deck of cards into this data structure called a dictionary. And then we'll use it in order to, this cards dictionary in order to create a blackjack game. So that's the idea. I mean, we could simply just go through all the different ways that you could use dictionaries, but I'm going to let the Jupyter Notebook handle those things and the keys and all this other business. What we're going to do is we're going to use a dictionary to I'm not going to call it solve a problem, but we'll say to help create this game. In creating this game, we're going to need some things more than just the idea of cards. We're going to need these other functions here, right? So I just went through and brainstormed before I started programming what I need in order to play blackjack. So if you see on here in the red are the things that I want to do in this video. So this abstraction of a card using a dictionary, actually a nest, like I said earlier, a nested dictionary. So it's a little bit more complicated than just a simple dictionary. But in general, I mean, if you're going to use a dictionary, they usually are nested or you know, something a little bit more complicated than just a simple dictionary. So I'm going to show you an example of how you would use one in order to do this. And then we'll create a deck of cards and shuffle them. So I need to have something that does that. I need to be able to deal a card from a deck. So once I've created this deck and it's shuffled, I need to be able to deal a card from that deck to someone's hand. And it doesn't matter, player hand or dealer hand, whichever one. And then once I've got a hand, I need to be able to evaluate it to know what the score is. All right. So that's the idea. And then later videos, we will program up the dealer strategy and the sort of, I'm not going to call it the player strategy. I mean, basically that's what we're talking about, but it allows the player to have input into the game, whether they get hit. I mean, really, if you think about it, what's the only two things you can do as a player? Well, we're going to make a simple version of a blackjack game. We're not going to allow them to double down, split, or any of that stuff. I don't want to get too complicated in this. You could later on sort of add that functionality to the game, but right now we're just going to do a simple, you either can hit or stay. So those are the only two things you get, and then it'll tell you if you win or not. So that'll be the last video. So the next video, I think we're going to do these two, and then the last video would be putting it all together to create a simple blackjack game. The idea of card abstraction. So what do I mean by that? If you just see a 5 and an H in your mind, you should be thinking of this idea of a card. And what is the idea of a card? And that's what we're going to try to capture. Not everything about that card, but the idea that maybe it's the 4th highest value card in a heart suit. Maybe it's worth 5 points in a blackjack game, and then 5H is the 5 of hearts. All right, so that's the idea. If you see the 5H, then to you that should mean it's the 5 of hearts, and we can do things in order to make that data structure sort of do the things that a 5 of hearts could actually do. Okay, so that's the idea. That's what we want to do. Let's start off. So this is I think I've already restarted the kernel. So this is, I don't need NumPy today. And you can see this is 15.1. We're creating a dictionary, sort of this game functionality. The things that we're going to use are these lists that we're going to create. So and you can bring up suit, and you can see so S stands for spades, clubs, hearts, and diamonds. That doesn't stand for all of it. S stands for spades, C stands for clubs, H hearts, and D diamonds. And then you can see the num vowels 2 through 14. Let's see, card face. These are just strings. That just came out of this little list here. And the blackjack values are 2, 3, 4. Okay, so let's check this one out. So let's look at that blackjack value. It's a list, and it goes from 2 to 10. So if you just go through the numbered cards, starting at 2, 3, 4, all the way up to 10, and then this 10 right here is for the jack. This one's for the queen. This is 10 is for the king, and this one's for the ace. So the ace right now is 11 points, unless you go over, and then you can subtract 10. So we'll do that once we do the functionality of evaluating a hand. We'll worry about decreasing that one by 10 later on. Card abstraction. So let's go ahead and start knocking this bad boy out. So I'm going to say that this cards is a dictionary, right? So that's new, a new way of thinking about, or a new way of bringing up a data structure, right? This is not a list, it's a dictionary, so it looks like that. And then for I comma s and enumerate. So we want to enumerate the suit. We want to have a nested. So for, let's see, J. Remember, I is the index, J is the index into this one, and then I'm also going to enumerate the card face. Card face. Oh, no, I'm sorry. That is C in enumerate. All right, so we get there, and then what do we want to do in here is we want, so I've had this dictionary called cards, and then inside cards, C plus S, we're going to set that equal to, we're going to initiate another dictionary. So again, like I said earlier, this is a nested dictionary. So you start off by initializing the dictionary here, and then going in, and then for each one of the numbers, C plus S, so think about what C and S are. This S is in suit, so it's the spades, clubs, hearts, diamonds, and the C is the card face, which is 2, 3, 4, let's see, 10. So T for 10, J for jack, Q for queen, king, and ace. So those C plus S's. Remember what happens with a plus? It's just concatenating those two strings together. So it'll be just like we had earlier, right? 5S, 5, string 5S. That will be the card 5 of spades. And we're going to make that a dictionary, and then after that, now we can start putting things in the dictionary. So C plus S, we want that. Let's see. Oh no, I want blackjack value. So I want to then have a. Let's see, do I want it to be capital? I think so. So blackjack value will be what? So BJ val. Let's see, yeah, that one. And then what value is it going to be for C plus S? So it's J. So it has to do something with the J, right? So it's the Jth one in that one. And then cards C plus S. Let's call it num val. So this is how you order, like, is one card bigger than the other one? Like a jack is smaller than a queen if we were playing some other game. And then num val, I think it's capital V. Yeah, okay, num val. And then that one also is J. It's the Jth one because I'm going through each one of these, and then the suit's going to come back up. Okay. And then cards C plus S. I don't know, face. So let's put face value. Face is equal to C. And then cards, call it suit. Suit is equal to S. And I think that's all we need. So let's go ahead and highlight everything here, press F9. And the question is, do we have, so the things that I want to test now are these things. And I didn't want to, I want you guys to just sit here, watch me typing them in. So a blackjack value, so let's see what cards looks like. I think that's might be an easier way to look at it, right? So it's a nested dictionary, meaning that this line here is a dictionary as well. So if I double clicked it, it is a dictionary for 2C that has a blackjack value of 2, a face value of 2, a num value of 2, and a suit of C, meaning the C comes along with it, which is a club. And you can see these are integers, the blackjack value and the num value, and that the face is a string. Here, let's do one that maybe a 10, maybe an ace, jack. Here, let's look at jack. So these have different values, right? So you get the blackjack value here, the num value is 11, the face value is J, and the suit value is H. So you can kind of see how these things are in the data structure called cards. So if I have a JH, then all of the I can access all of the information that's in here. So if I have the card JH, then I can find its blackjack value, I can find its num value. Well, how can you do that? It's just as simply as just doing this. So if I had a jack of hearts, then I want to know its blackjack value. I just pass in BJ value and it gives you 10. If I had a jack of hearts, I want the num value, then we see it's 11. If I want the face, J. If I want the, what was the other thing? Suit. If I want the suit, then I get H. Okay, so that worked. That is the idea of a card that has these attributes that are associated with it, and now we're going to build in some functionality. So the first thing I want to do is I want to be able to shuffle a deck. So I'm going to have def. I'm going to call it new deck at first. Shuffle a new. In other words, like once you've passed out all the cards and you've pushed them to the side, and now you're going to use more cards for a blackjack game, and then you push those to the side, and you're going to use more cards. Eventually, you're going to have to get all of the cards, all 52 cards into the deck, and you're going to shuffle them up. So that's what I mean by new deck. It's not necessarily one that's coming out of the package. It just means a deck that has 52 cards in it that is shuffled and ready to rock and roll. So that's the idea behind it. So we get new deck is equal to that, and then suit is equal to list. So we're going to do the same thing that we did up here. I'm going to grab the card value and I'm going to grab both of those lists and throw them into here. Card face, and then deck is equal to list, and then 4S suit, card and card. Was it card face? Yeah, card face. Then we want deck dot append to be C plus S. So what you want to do is make sure that you're using exactly. So if you did S plus C up here, you better use S plus C here, because these have to match in order to be able to get to this information that's in here. So this list that comes out of here needs to match exactly what you did before. Oh, did I append it? Yeah, I did. Deck dot append, and then deck. For right now, let's just return. Let's run it. F9, and just get a new deck. F9, print deck. All right, so you see that's 2 of spades, 3 of spades, 4 of spades, 5 of spades. So the problem here is we don't really have a way to shuffle it yet, right? So now what I want to do is inside this function here, I want to now shuffle the cards. And we'll use, I think we've used this before, maybe not, but we're going to use the shuffle command. So I'm going to say def shuffle, let's say X, it doesn't matter really what it is, RD, make sure I pulled it in as RD, yeah I did, okay, so RD dot shuffle X, and then just return I guess we don't even need that. Let me just get out of here. I don't need all this, because I know what shuffled. I know what rd.shuffle does, and I could probably use np.shuffle, and I didn't even need to do it, right? So before I return deck, I want to say deck is equal to rd.shuffle deck. Just do that. I was going to get all fancy and put a function inside a function, but you guys, hopefully you know you can do that, but maybe not. Ooh, it didn't like that at all. Maybe I didn't. Oh, I didn't pull this in. Sorry. So F9, and then I don't think I have to redo that. If I do, we'll come back and do it. All right, deck, and then let's print it. Ooh, that's not good. Oh, okay. Yeah. So shuffle doesn't return anything. You just need to do that, and it actually shuffles it. So if you do the shuffle command, whatever list you put in there, it will keep it. It sticks, if you will. So let's try it again. and come back and run this, F9. And so now we have 7 of hearts is the first one. And now you can kind of see what's happening, right? So every deck now is new and they're shuffled a different way. So that's pretty cool. Now, how am I going to use the cards, this dictionary that we created up here, in order to, along with this deck, in order to get information out of it? So now I just do cards, deck 0, blackjack value, and we get 10. Let's do a couple more. F9. So that's also a 10. 7C is a 7. Ace of spades is an 11. Jack of clubs is a 10. So you can see what's going on here. So now you just give me a deck of cards, and I can start, and I can use my cards dictionary in order to get whatever information out of it. I could put blackjack value. I could put suit here. I could put num value. We could get that information out. Okay, so that's a new deck. Now let's create. Let's create this function that's going to deal cards to a hand. So what do I want to do when I deal a card? So deal card. I claim that you need to input into this function a card and a hand. Right? I'm sorry, not a card. A deck and a hand. So you see, you have to tell it what the deck looks like, and then all it's going to do is take a card off the top of the deck and put it into the hand. So that's, I mean, it's a very simple function here. So card is equal to deck.pop. Now, if you just leave it like this, it'll take it from the back of the hand. So instead of the jack of clubs, it would take the ace of diamonds. But we want to simulate this thing like this is the top of the hand. So I'm going to say, I mean, again, it doesn't really matter, to be quite honest with you, but I mean, for visual sake, we'll just make sure that it pops the 0th one, so the very first one that's in the deck. So if we print something out, we would expect it to come off the top of the deck. And then once I've got the card, all I want to do is simply go hand.append card. It's that simple. And then I think we're done. We just return deck and hand. Return a deck in the hand, and you should be good to go. All right, so let's come down here. So go to my, so we got a new deck here, and then let's see, print deck, player. So I've created this player hand, which is a blank list. Dealer hand was a blank list, and then I'm dealing 2 cards from the deck to the player hand, from the deck to the dealer hand. All right, and let's find out what happens. So let's run this. Hopefully this works. Did I forget to do it? Yeah, I forgot to. F9, and then let's run this again one more time. Ooh, it didn't like that. Why did it not like it? It has no attribute. So hand.append card. Tuple object has no attribute append. Why is hand should not be a tuple. Deck hand, deck player hand, F9, tuple. Why would it think it's a tuple? Okay, well, let's go back up here. Let's make sure. Why would it think it's a tuple? Tuple object has no attribute append. I agree with that. Let's just print hand right here. And right before it gets that error. Hopefully, player hand. Oh, hold on. Yeah, I see what I'm doing. So right now this is I need to tell this as the deck, comma, deck. That's what's happening. So the first time it goes through, it thinks it's I don't need to do this print stuff anymore. What it did, so I'm returning a deck and a hand, but I was only assigning it a player hand. So what it did was it thought player hand had 2 components to it. A deck, which was on the left hand, you know, the first thing, and it makes it a tuple, and then a hand, which is whatever first card was in that deck. Yeah, that would be a problem. Did I do this one? Yeah, I ran this one again. And now let's try it one more time. All right. So let's see what happened here. So deck was equal to this. And then it went through and it printed player hand. Oh, why did it do that? Oh, it printed it because I told it to earlier. I didn't redo it. Let's try it again. All right, now all I was looking for was the deck that it started with. Oh, and I guess I could print deck too. See what it ends with. Because what I'm looking for is for that 5 of diamonds to be in the first hand, the 3 of clubs to be in the second hand. So that's the player hand. This is the player hand. This is the dealer hand. And then the 8 of hearts to be in that one. The 2 of hearts be in that one. And then these should not be in when I hit go. It should start with the 10 of hearts. So if that happens, yes, we are correct. So everything's right. And then you can go length of deck. That it has 48 cards, and I have 4 cards in the hands, and we're good to go. So it looks like deal is working. And if you don't believe it, you can run it a couple times. You really want to make sure these functions work correctly, exactly how you think they should work before you sort of let things go. So AD, 5H, TD, KH. All right, so that looks good to me. And then you can look at length of hand again. You can deal another hand if you want to. Just make sure that it works past that. Both of them. So I dealt another card to the dealer hand, and that looks like what we got. Okay, I think that looks like it's working. So now I think the most difficult function so far, these other ones are kind of easy. I think the most difficult one that we're gonna do is maybe this blackjack eval function. So let's that one, blackjack, and all we need to pass it is a hand. And then what are we gonna do? Well, I'm gonna initialize hand value is equal to 0. Maybe ace. We need to keep track of the number of aces that we have. Because if your hand value is greater than 21 and you have an ace in your hand, then you can subtract 10. So that's the idea behind it. All right, so then for C in hand, so for card in hand, all we want to do is go hand val plus equals card. So again, I shouldn't say again. This is probably the first time that I mentioned this. I am assuming at this point that this cards dictionary is a global variable and I can just access it anytime. So I'm accessing without passing it into here. Another way to do it is to pass in the dictionary in every time I'm going to use it. But I'm assuming that it's this overall global variable that I can just snag anytime I want to and use it. And so that's why you see it that I didn't pass it in here. So cards, C, right? Because C is the card in the hand, and remember what the hand looked like. It would be 5H or KH or 7C, and so it's going to go through there. It's going to grab. Let's see. I need the value, so I need blackjack value, and hopefully that's what we used. Let's see, cards, BGA, val, capital V. Okay, good. And that will be the number that comes out of that guy. And then we're just going to add them all up. And then so we need to keep track of how many aces that we have. So if cards, C, face is really equal to an ace, then what do we want to do? We simply want to say ace plus equals 1. So ace, and now get out it. So now that just kind of goes through and does the initial, how many points are in your hand if all aces are 11. That's all this first part does. And if we're greater than 21, well, we need to do some, and you have an ace, well, we need to do some backtracking. So if you're not greater than 21 and you counted the aces 11, you're fine. You just leave it like it is. I mean, if you had 4 aces and a 10, that would still be 14. And I'm sorry. Yeah, that would be 14 because all those suckers are counting as 1. 11, hold on, 3, 11 plus 3 is 20. Yeah, so yeah, I mean, it's sort of hard for me to do the math on that one, but, or sorry, just kind of visualize that one. Let me think for a second. So if one's 11 and I had a face card, then that would, yes, then that would, you'd be more than 21. So what are you going to do? So hand val is greater than 21, and ace is also non-zero, not equal to 0. Then we simply, so now we're going to subtract. So hand val minus equals 10. And then I also got to subtract 1 from ace, otherwise it would always just be, it would never be greater than 21. Or if you had an ace, you'd always be good. That's not the case. Let's see why. And then, let's see, am I done here? So I'm going to go through, I'm going to add up all the points. And then if it's greater than 21 and I had an ace in there somewhere, then it's going to subtract and subtract 8. Okay, that looks like I'm done. Return hand val. And now what do you think we're going to do here? Hopefully you're thinking, I got to test this thing. I got to test it somehow. And so let's go down here. Let's test it. I'm going to take out that. I'm going to take out all this print business. I will leave that one in there. I don't need to see the deck anymore. I'm pretty certain that this thing is working. F9. And now I want to evaluate player hand, which player hand is that first one. So that should be an 11 plus 9 is 20. I forgot to run this. All right, let's come back down here again. Player hand, dealer hand, and eval player hand. We get 20, so that's good. So that is correct. And now it should be a 10, and it is. Okay, let's deal another hand, or another card to the player hand, because the player's got an ace right now. So let's deal another card to him. And now let's look at it. So I got an ace, 9, and ooh, this is nice. This is good. So I got an ace, a 9 in it. So that should be a 9, and that should be 21, right? That should be 21. Fantastic. And now I'm going to be the stupidest player in the history of blackjack. I want to deal another hand card to my hand. And this one should now be, because I have 2 aces, so 10, 19, 20, 20 should be 21 again. Okay. So you see what it did is it added those 11s, and then it had to subtract off each one of those 21, or each one of those 10s to get us to 21. All right, so I'm pretty sure this works. Let's do another one to the dealer. Check him out again. 20. Oh, I forgot to print it. 20. Is it 20? Yes. So let's make sure that something actually busts, because I haven't seen it bust yet. I'm gonna make the dealer bust. Everybody likes the dealer to bust. And print the dealer hand. So 25, is that correct? 10, 25, yes. All right, perfect. Well, we got the functionality, we got the idea of a card. Hopefully I didn't take too long on this one. I don't think the other ones are going to be as long. So just tune in for the next 2 lessons, and we'll talk about the dealer strategy using this dictionary, and then the player strategy also using this. All right, take care. See you next time.